Page 6, nuclear notes, how to write a natural transmutation or decay reaction, a nuclear chemical reaction. So here are some steps. So first, we're being asked to write the nuclear decay reaction for Au-198, gold 198. So the first thing you want to do is go to your table N and find gold's decay mode. So when you go and look at the decay mode, it provides this symbol, which means it's beta. So the decay mode is beta. So if I'm not sure how to represent the beta, then I can look on table O, and I can see that the beta symbol, I'll see in the reaction, it's an E, superscript of a 0, and a subscript of a -1. You must have the -1 in there. So now it says write the correct notation for the particle emitted on the right hand of the arrow. So I'm going to go with 198 Au gold, put my arrow, and based on what I found on table O, I am going to put it there. So now it shows me my unstable nucleus, gold 198, its nucleus falls apart, and this is that radiation given off. This is the scary stuff. Okay? Now, what I need to find out is what is the new structure formed as a result of the nucleus spitting out the beta particle. So you need to remember to determine the charge and mass of the unknown product. That's where above I put the question mark. The charge and mass on the left must equal the charge and mass on the right. So if I take a look, my total mass on the left is 198. The beta particle takes 0 with it. So my question mark must have all of the mass with it, 198. Now, what I need to know is what is Au's atomic number. So I go to my PT and I find, oh, that's a 79. Well, the beta particle, notice it has a -1. So to come up with this atomic number, my sum, 79, equals the -1 from the beta particle plus X gives me the atomic number. So -1 plus what value will equate to 79? Well, if I think about the algebra, and I just do the math as if I was in math class, so I add -1 to this side, cancels that out, and that becomes 80. So X must equal 80. So now let's come up with the total final reaction. So I have gold 198, and I'll put in its atomic number 79. It decays, it spits out that beta particle, and the new structure formed has a mass of 198. It has an atomic number of 80, and I need to go to the periodic table to find its symbol, and I look it up, and it's Hg. So if I pay attention, total mass on the left is 198, 0 plus 198 on the right is 198. My total number of protons I'm showing here is 79, and I'm showing a -1 plus 80 would also equate to 79. So here is the nuclear decay of gold. You need to use this type of process for any type of natural transmutation reaction. So the alpha decay. So this is my decay mode. Okay, so right away, I would go to table O to look at my notation for the alpha particle, and I'll see according to table O, you see the alpha symbol, looks like a fish from the Greek, but in a reaction to help show the mass and how it affects the atomic number, we would show it as this symbol. So since I know that Rn 222 goes through an alpha decay, right away I'm going to write down that alpha particle symbol. This is the bad stuff. This is the stuff that is scary when the nuclear reaction is occurring. Now we need to figure out what is the new structure formed. So once again, total mass on the left must equal total mass on the right. So Rn has a mass of 222. The alpha particle takes 4 with it. So if I can do my math, the new particle has a mass of 218. On the left-hand side, the total of the atomic number is 86. The alpha particle takes 2 of the protons with it. So the new particle keeps the remaining 84. The new particle has a different atomic number than Rn. Therefore, it has a different identity and a different symbol. So I have to go to the PT to find out which element has an atomic number of 84. And when I look it up, I see that it is PO, polonium. So Rn is unstable. Polonium 84 compared to Rn, it is, I'm going to say, more stable. It doesn't have the perfect 1-to-1 ratio of protons to neutrons, but its ratio of protons to neutrons is closer than radons. The summary of an alpha decay, you should notice these things. So in the summary, the atomic number will always decrease by 2. Comparing the new structure to the original structure, new structure will always have 2 less protons. So therefore, the number of protons decreases. Notice, the mass, the alpha particle takes 4 AMUs with it, so the new structure's mass will always be 4 AMUs less than the original. So the mass decreases by 4 AMUs. So now, neutrons. So you have to remember, mass minus the number of protons equals neutrons. So, in the original structure, 222 minus 86. So 12 minus 6 is 6. So that makes this 11. 11 minus 8 is 1. And we have, so 136 neutrons in our Rn-222, right? And then in our polonium, we have a mass of 218 minus 84. So 8 minus 4 is 4. 11 minus 8 is 3. So we have 134 neutrons in our polonium-218. So the difference between 136 neutrons and 134 neutrons is the number of neutrons decreases by 2.